Good morning, good afternoon, good evening, whenever and wherever you are. My name is Anna Rochelle, and today we are going to continue with Geometry Chapter 8. This is, again, a student sent in some review questions for this chapter. So we're going to go ahead and just jump right into it. So we have solve for x. The polygons in each pair are similar. So realistically, we're looking for something that looks kind of like it's pointing in one direction, right? So in this case, I know that these guys are kind of like the longer pieces, right? It looks like it's kind of like an arrow pointing in that direction. And then this section right here is like the smaller section here, right? So we're looking for things that are similar so that when we do these problems, we can create this fraction that we're looking for, right? So I know that the 35 and the 42 are similar, so I'm going to put both of those in the denominator. So I'm going to put 35 for the smaller triangle, 42 for the larger triangle. My larger pieces are going to be 20 and this 5x minus 6. Once I have my proportions set up, I can go ahead and cross multiply. Before I cross multiply though, I do want to simplify as much as possible to make my life a little bit easier. So I'm going to divide both of these by 5 to get 4 and 7. And I also know that I can divide 7 and 42 by 7 to get 1 and 6. So my new proportion is 4 over 1 equals this 5x minus 6 over 6. And realistically, when I multiply anything by 1, it's just the same thing. So I'm just going to go 5x minus 6 equals this 4 times 6, which is 24. I am not a fan of this yellow. Okay. We add 6 to 24. We get 5x is 30. Divide by 5 on both sides. X is going to be 6. And because all they say is you just need to solve for x, we're fine to leave this as is. They didn't say find the length of that line, okay? And here we also have solve for x. So what we do know is we have these two triangles that are similar. So one thing that I want you to notice is that it's FGH. So when we're looking for this, we're going F, G, and then H, kind of in this pattern. So whatever this line is going to be congruent to in there, we're going to go ahead and take a look at what that is. So this is going to be FBA, so we're going FBA in this direction. Realistically speaking, I know that this and this correspond to each other, and this correspond to each other. They're not congruent, so I don't particularly love that fraction. But one of the things that we can do is we can actually say that in this particular case, when I'm looking for a fraction, this over this is equal to that over that. When I do write this fraction in, and I have this 96 over 9x plus 6 equals to 40 over 40, I know 40 over 40 is just 1. So really, I can say that this 9x plus 6 is the same thing as 96, right? Because I know these two are congruent, so I know these two will also be congruent. I'm going to subtract 6 from both sides in order to find that. 9x equals 90. Divide both sides by 9. X is 10. And then because they say solve for x, I'm going to leave it as solved for x. Same thing in here. I would like to, actually, I'm going to go ahead and erase before I do another problem because I feel like we're getting a little bit too much. So let's see if we could scroll down here. I'm going to go in and create this black screen here. And we'll do that. Okay, let's make another line. Okay, cool. So in here, I can see that QR and FE are similar. So I'm going to kind of put a little tick, but I know that they're not the same. They're just similar. So that leads me to believe that this 2x minus 12 and this 4 are also similar. So what I'm going to do is I'm going to go 2 over 4 because this over this, like little over big, is going to be this little, this 4 over this 2x minus 12. It's a weird looking equals. It looks like it's got a happy face. Again, I'm going to go ahead and simplify as much as possible. So this is going to be 1 over 2. I can factor out a 2 from here and go 2 times x minus 6. I can also simplify this 2 and 4. Let me get a different color. So 2 divided by 2 is 1, and 4 divided by 2 is 2. So then really my entire set of parentheses goes in, or sorry, my entire fraction turns into 1/2 equals 2 over this x minus 6. I'm going to go ahead and cross multiply. Whoops. 4 equals x minus 6 because anything times 1 is 1. Add 6 to both sides, and I'm going to end up with x is 10. And again, because they only ask me to solve for x, all I'm going to do is leave it as is. Okay, so let's go ahead and let's continue. So now we're talking find the indicated length. Now these are also very similar. The only difference with these is that I kind of like these a little bit better because you can actually go in and the do the fractions, setting up one fraction with another fraction a little bit easier. So let's start with the easier one first, and then we'll move on to problem 25. So this one's really nice because I can just go in, okay, 15 over x is equal to 9 over 6. When I do that and I get 15 over x equals 9 over 6, again, you can simply multiply just straight across and get 9x equals, whoops, 15 times 6. 15 times 6 is 90. That looks a little weird. It gave me like a funky number. I think I put something in incorrectly. And then I divide by 9 on both sides, and then I get 10. And that's it. They're just saying find the missing length. And because I know that this is the missing length and that was a question mark, that's it. I'm done. Moving on, right? Like there's not so much that I need to just sit there and worry and think and focus about, right? In here, it's a little bit different because in here, I actually have to go in and I actually have to figure out, hey, what is this piece right here? So because I'm given that the whole thing is 27 and part of it is just 15, I can just say, hey, this part right here is 27 minus 15. And that's going to be 13. So I'm going to say this part is 13 right here. Now I can actually go in and I can say, okay, I know that the whole thing is 27. So I'm going to create a fraction that's basically like the whole line over part of the line. So what does that mean for this side? I can say the whole line is actually 27 units and part of the line is 13 units. The reason why I'm choosing 13 is because this is where my unknown length is, and I want that section to be in my unknown. And then in here, I know that this portion is 45, so I'm going to go 45 over x. And again, I'm just going to go in and I'm going to cross multiply. You can't, if you can simplify, definitely go ahead and do that. In this case, it's kind of like only being able to simplify this way. So I'm just going to leave it as 27x equals 585, and I'm going to divide by 27 on both sides. And I'm going to get x is about 21.67 because it's 0.66666 forever. And so we're just going to say it's about. Typically, when I have problems that look like this, I would say either leave it rounded to the nearest 2 decimal places because you're not in a trig lesson, you're not in a trig class. So it's totally fine to leave 2 numbers after the decimal point. Or just round it to the nearest whole number. So another way that you can do this is say it's about 22. Both I think are totally reasonable answers. Okay, let's clear this. Okay, so now let's take a look at what's happening here. In the other video, when I was talking about chapter 8 of geometry, we were taking a look at how we had these two angles that were kind of the same. Knowing that these two angles are the same, we can say that we have a similar proportion, right? So if this side is x, this portion right here would have to be 10 minus x. So this is exactly where my fraction comes into play. I have 10 minus x over 14 equals this x over 6. Once I know that that's my proportion, I can absolutely go in, set it up. Fraction over one fraction equals another fraction. I can cross multiply. Again, if you can simplify, definitely simplify. We know that we're going to have this 6 going to be distributed to here and here. That's going to equal 14x. So I've got 60 minus 6x equals 14x. Add 6 to both sides. That looks like a weird, I don't even know what that was. Okay. So 60 equals 20x. I'm going to divide by 20 on both sides. So x is 3. Again, because they're saying find the missing indicated, like find the missing length indicated, and we're just looking at this portion here, we're only going to say it's 3. 3 units, 3 whatever. Okay, let's go ahead and let's take a look at this. So the student who attempted this, who sent this in attempted this problem. And let's go ahead and let's take a look to make sure that we've got the right thing happening here. So x over 5, correct, right? So we've got this fraction here equals this fraction here. 100% correct. We would set these two equal to each other. We would get 5 times 6 is 30, 3 times x is 3x, and then divide. So this is beautiful. This is totally acceptable. Okay, so here we've got this x plus 1 is on this side. We really do need to figure out what this length is, which is nice that we can do that because we can just do 21 minus 6. So if I do 21 minus 6, I get 15. So this portion is 15 here. I'm going to go ahead and create this like block over here so that I can do some math in a nice fashion. Okay. So again, in here, I can say, hey, here's one fraction and that equals another fraction. And it's gonna be this over 15. So x plus 1 over 6 equals 25 over 15. I would simplify this to make my life easier and divide both by 5 and get 5 and 3. I would also simplify this and this to get divide by 3 and get 1 and 2. So then really my entire proportion is going to look like this. And then I have this x plus 1, right? So I'm going to go ahead and cross multiply these and cross multiply these. So equals 10. Well, now I know that x is 9. And then that's it. That's my final answer because I'm only solving for x. Let's see what's happening here. So we've got 15 over 10. I like that. Equals, okay, so this I'm not a fan of. This I am not a fan of. So let's go ahead and let's take a look at this and let's make it look a little bit different. Okay, I like the 15 over 10. I think the 15 over 10 is super helpful, but this portion here, and I'm going to erase everything here for a second. Okay, I know that right in here, this portion from this point all the way to this point, this whole little section here, is going to be this 1 plus x, this whole section here, minus 4. So I'm going to have in my numerator 1 minus x, but then the whole thing is going to be minus 4 over 4. So if you can tell, this fraction right here is going to be equal to this fraction right here. But this section is this whole, oh, whoops, 1 plus x minus 4. So this whole section is going to be this big portion minus the little portion. So I'm going to go ahead and I'm going to simplify this top section, and that's just going to be, x minus 3. I'm also going to simplify this section by dividing by 5, and that's going to be 3 and 2. And then I can go in and I can simplify the 2 and the 4 and say 2 goes into 2 once, 2 goes into 4 twice. If you don't want to simplify, not a problem at all. You just go ahead and you can cross multiply originally. You will have to go ahead and combine like terms here. So you will go in and you will go 1 minus 4 is negative 3 and then leave the x. So you'll be left with 3 over 1 is the same thing as x minus 3 over 2. I'm going to cross multiply these guys and these guys. Be left with x minus 3 equals 6. Add 3 to both sides. X is 9. And then I'm good. I've got this whole thing down. I don't want you to think about these problems and be like, oh my goodness, this is so tough. I can't do this because I don't know what that little portion is. There's always a way to figure out that little portion that you're not given. So you should definitely go in and just try it out. Like, see what happens. What if you can subtract? What if you can add? What if you can, whatever the case may be. Oh, I don't know what I did here. I just wanted to. Well, I guess I have to live like this. Okay. I was hoping that I could cancel some of this stuff out, but I guess not. I guess I have to work on it this way. Okay. So let's take a look at 13. 13, again, is the same business. In order for me to figure this portion out here, I'm going to go, what's 28 minus 12? Because I'm taking the whole entire line here and subtracting part of it, right? So 28 minus 12 is going to be 16. So here's my fraction. 15 over 12 is 4x over 16. Again, you can simplify or you can just multiply straight across. So, multiply in proportion form. So we can multiply like this. So we're going to end up with, 15 times 16 is 240 equals 48x. Whoops, that's a funky looking x. And then I'm going to divide both sides by 48. So 240 divided by 48 is 5. And that's it. I'm leaving it as is because I was only asked to find what x is. If I needed to actually find the length of this entire line, I would just do 4 times 5 and get 20. In this particular case, I have the whole, right, for both of them. And here I have this top part, but here I have this bottom part. And ideally, I'm looking for this top part so that I can have a proportional relationship. Whole over top part equals whole over top part. We're looking for something similar. I can find this portion out by doing 18 minus 10. So because I can do the whole minus the portion and I can get the other portion. And this is it. This is my proportional relationship. I'm going to go in and do a different color to make it a little bit easier to follow along. 27 over 4x equals 18 over 8, right? Because I did the whole over the small equals the whole over the small. Again, we can simplify or we can cross multiply. Whoa, boy. Something is fishy over there. Okay, so 27 times 8 is 216. 4 times 18 is 72x. And then I'm going to divide both sides by 72. So 216 divided by 72 is 3. So x is 3. Again, I don't need to do anything else after that. I'm going to go ahead and create this little bracket or, well, I guess little covering. Okay, so let's take a look here. I know that here I have this like longer portion, but here I have the shorter portion. So same idea, same principle, right? I have the total and I'm going to subtract this little guy to get 4. And now I can do the total over the big guy equals the total over the big guy. Meaning I'm going to have the total over the big guy equals the total over the big guy. And I can go in and I can just cross multiply here and cross multiply here. 40 equals 4 times 4 plus 2x. Distribute. I can get 40 equals 16 plus 8x. Subtract 16 from both sides. I end up with 24 equals 8x. Divide by 8 on both sides, x is 3. Again, I'm only being asked to find x. If I needed to find the total length, I would just go in and say, okay, 4, whoops, not 4 times. 4 plus 2 times 3, which is 4 times 6, which is 10. So 10 would be the full distance from here all the way to here. That's all I'm looking for. Here, the same thing. I have a fraction. 6 over 9 equals this fraction, 10 over x plus 8. Every single one of these problems, it seems like the student was struggling with the very first one, didn't know how to start. And then since all of these problems are exactly the same, we're just doing the same problem over and over again. But you just have to find out which fraction is where, right? So 10 times 9 is 90 equals 6 times this x plus 3. I'm going to distribute the 6 to everything. That becomes 6x plus 18. I'm going to subtract 18 from both sides. Whoops. I'm going to end up with 72 equals 6. Why does that not look right? 72. Okay. And then x is 12. That seemed a little fishy for a second. Again, because it's only asking me to find x, I leave it at that. If it did, I would just plug it into this particular x plus 8 business. I hope that this was helpful, and I look forward to seeing you in another video. Bye.